we are continuing with the 2016 release test, starting at problem number 34. It says the graph of the quadratic function is shown on the grid. The coordinates of the x-intercepts and y-intercepts and vertex are all integers. So these are all integers. Now what I'm going to do is I'm going to do different colors here. All right. So let's do x-intercepts in blue. Let's do y-intercept in red, and we'll do the vertex in green. Okay. So the x-intercepts. Well, right now we're just going to continue recording real quick. We're going to do x-intercepts in blue. So it's kind of hard to see, but right there, if you put a point right there, that looks like that's at 8 and 0. Get your magnifying glass out here. That right there, you can probably look on your paper, that's a -4 and 0. Okay, now we're going to plot the y-intercept. So the y-intercept is right there. So that looks like that's at a 0 and an 8. So that's my y-intercept. And then it says the vertex. So the vertex is either going to be the lowest point or the highest point. So if you look carefully, that's the highest point. And that ordered pair is at a 2 and a 9. So that's your vertex. Now this vertex is also known as a maximum. Okay. All right, so now if we look at this question, it says, what is the maximum value of g? Basically, g is talking about the parabola. Okay. Well, it looks like it gets all the way up to, what's the highest value? Yeah, that's going to be our maximum value. That's the biggest that it gets. So that answer would be 9. Do you have to write it in? Oh, it says, record your answer and fill in the bubbles. So what you would do is, like if there was a box, right? You have these boxes and they have a whole bunch of what? Bubbles. It looks like this, all right? So basically, you just put a 9 here, okay? Now you could put actually a 9 over here if you wanted to. Just don't put a negative. Make sure you keep it positive. If you don't fill in, they'll have a plus sign and they'll have a minus sign. You don't have to fill in the plus sign if it's positive, but you do have to fill in the negative sign if it's negative. And then what do you do down here? You bubble in the 9 way down there. That's what you would do. And that's not a very good box, but we're moving on for time. Okay, here we go. An organization has a monthly budget of X dollars. Okay, so they have a monthly budget of X dollars. Whenever I'm doing word problems, I always write down what X means. X equals the monthly budget. Write it down. X equals monthly budget. All right, every month, 2,070 is spent on salaries. Okay, so we got 2,070 is spent on salaries. Okay. 1/4 of the remaining budget is spent on monthly activities. So 1/4 of the remaining budget is spent on monthly activities. Which function can be used to find the amount of dollars spent on monthly activities? So think about this. What do they spend every single time? They spend a certain amount of dollars. Okay. Now, every single month, how much do they spend? All right. So 2,070 of this is spent every single month, right? So we got to figure out 1/4 of the remaining budget. So we got to take basically 1/4 of whatever we have left. So let's think about this. So X, that's the total, right? That's the total. What's going to be basically used every single month out of that monthly budget is, now why did I put a minus sign there? We didn't take it because that's my total. So let's say your total budget was what? 4,000. Okay? Well then if 2,070 is your salaries, that's what's spent every single month. What I want you to do is I want you to say this right here, X minus that is what is left. X minus 2,070 means that's what's left over after you've done that. Okay? Now out of this, what is used on the monthly activities? Okay, but how much it says what? 1/4. So not all of it, right? What are we going to take from this? Just 1/4 of it. So we have to take all of this, right? What are we going to multiply it by? 1/4. Or multiplying by 1/4 is the same as dividing by 4, correct? So which one of these is being divided by a 4? D. Okay? So now they could have also, by the way, this is another way they could have written 1/4 of what's left. So I'm just saying, they could write it this way. You can also write it this way, all right? So let me explain to you. There's more than one way to write it. So this is how they wrote it. F of x equals, or you could have written it like this. 1/4 of x minus 2007. So either one of these would be correct. All right? That just happens to be the one that's this one. Okay? All right, moving on. Number 36. Ooh. These are games. Okay? All right, it says which table represents y as a function of x. Now, here's just a little shortcut. All right? Just remember this. Each x value can only have one y value. Each x value can only have one y value, which means each input can only have one output. Now, sometimes kids are like, wait a second. I was always told x can't repeat. Like, that's fine. If you want to write that down, put x cannot repeat. You could also put that down just to help you out. Okay. Now, right here, do we have repeating x's right here? Yep. We have repeating x values. Do we have repeating x values right there? Yep. Do you have any repeating x values? No. This one has all repeating x values. Basically, it's what they're saying is each input can only have one output. If you plug in a 2 and you get a -1, you can't plug in a 2 and get a -2. When you plug something in, you should get one answer, not two different answers for the same number. You shouldn't get two different outputs for the same input, is what it's saying. So this is the only one where each x value has one y value. Do you see x repeating? Okay? You don't have to worry about the y's. Right now, you just got to worry about the x's. Okay? Each input has one output. Okay. Number 37. It says, which statement about this is true? So right now, you see where it says zeros and zeros and zeros and zeros? All we got to do is find the zeros of it. So by the way, let's use Desmos right here. All right? Type this into Desmos. You don't even have to put f of x. All right? You can put y equals, and just type in 2x squared minus 3x minus 5. Okay, so we're going to do that right now. Go to Desmos. Technically, you don't even have to do y equals, but I'm going to just for fun. Y equals 2x squared. Look over your shoulder. Minus 3x. And what? Minus 5. All right? Hey, see that? And that? You know what those are called? That's right. Those are the zeros. Can you write those down on your paper right there? Jot them down. Got -1, right? -1, 0, and what? 2.50. Now, that's the decimal. The fraction equivalent is 5/2. Now, if you didn't know that, you have a graphing calculator you can use as well. You could do 2.5. Hit the math button, press enter twice, and what does it change to? 5/2. All right? So, let's go back to our problem. So our zeros, you should have written out -1, 0, and 2.50. Also, its alias is known as 5/2. That's the improper fraction. All right? So are the zeros at negative 5 over 2? No. Are the zeros, no? Are the zeros at negative 1 and 5 over 2? Yes! Boom, just by knowing that. Now these are the factors of this. Now check this out. See this right here? Type it in. Type in parentheses, x plus 1, parentheses, 2x minus y. This is really cool. Just to be sure, ready? Put y equals, I'm going to open up the parentheses, I'm going to put x is x plus 1, right? Then it was, open parentheses, 2x minus 5. What do you notice? Same thing. This graph is the same as this. So if these are the same, that has to be the right answer. Does that make sense? I hope so. Man, so much you can do with this. Alright, let's go back up here. Scroll down. Here we go. Oh, man. Okay, we'll zoom out just a little bit. Okay. There we go. It says, the graph shows how the volume of gas sample changes as the temperature changes and the pressure remains constant. Alright, so it looks like what happens. As the temperature increases, what's happening with the volume? Volume also increases. Now this is a linear function. How do I know it's a linear function? Alright? No, because it's a line. Yeah. It's a straight line, so we know it's a linear function. Okay? Now, the thing it's asking you for right here is what's called the rate of change. By the way, the rate of change, you know what word is always means the rate of change in a linear function? There's another word. Slope, that's right. Anytime you see rate of change, think, hey, it's asking for the slope, the rise over the run. Like, it's called the change in y over the change in x. Alright? So, let's think about some points we can actually look at here. Alright. Oh, hey. Let's look at this point. Can you see that point right there? I'm going to make a little table. Alright? Let's make a little table. We'll call this the x-axis, right? That's the x, and we'll call this the y, part of the table. So what would be that ordered pair does it look like? Between a 20 and a 40. That would be a 30, yeah? Okay? And if I go at the 30, what is this number right here? That's 20, 21, 22, 23. That looks like that's at a 24. So that's a 30 and a 24. Now I'm going to scan the line, scanning until I find another perfect ordered pair. Does that look like a good ordered pair right there? Pretty close. Let's see if I find it. How about this one? That looks pretty good. Oh, by the way, you ever see that? Like, you ever look at crosshairs, like in a sniper rifle or something like that, where you have like X, right? You're looking for where the line hits perfectly right there. So so right here, it doesn't hit perfect until it hits that point, and then it doesn't hit perfect until it looks about right there. But it can also, I'm gonna use this one. If I go down, that one's at a 90, and over here it looks like we're at a 29. So like I'm at 90, and all the way up here I'm at a what? 29. Okay. So this ordered pair is what? At a 90, 29. This ordered pair is at a 30 and a 24. Not a very good four. So right here, what's the gap? What's the change in y? What do you guess? Goes up how much? Plus 5. What's the gap right here? How much is that for? From 32 up to 90. What's the change in x? What would you say? No. It goes up like how much you added. Oh. Yeah, 60. See how easy that is? Mm-hmm. That went up 5, that went up 60. What did I say slope is? Change in y over change in x. So what is our change in y? 5. What is our change in x? 60. 5 over 60. Ooh. That reduces to 1 over 12. 1 over 12. That gives us answer choice G. Now, by the way, you should be able to eliminate these two, because these are really steep slopes. A 12 over a 1 means it goes up 12 and over 1. So that's not what's happening. Okay? So it goes up. We went up what? Up 5 and over 6 feet. Alright? One second. Alright. Here we go. Number 39, it says, what is the what? What is the solution? By the way, whenever you have two lines, okay, that's a line, that's a line. Whenever you have two lines and they cross anywhere, wherever they cross is called the solution. The solution will have an x coordinate and a y coordinate. So, since we have Desmos, we're just going to use Desmos to show you how to do it. I'm not going to do this one by hand, just for sake of time. But right now, we're going to type it in Desmos, and we're going to see where the two lines cross. Okay? So one of them, I'm going to go and close this out. Type in. First one is what? 10x minus y equals 53. Okay. And the other one was, we had a fraction, so I've got to find my fraction bar, but I'm going to go ahead and do, I know I didn't do y for the first time, but I'm going to go ahead and do parentheses, negative 13x plus 92, close parentheses, close, oh, messed up. We're divided by, there we go, divided by 2. So, by the way, here's something you have to do in Desmos, okay? If you're going to do the fraction bar, you got to make sure in the numerator you put it in parentheses. Remember that, okay? Put it in parentheses. Now, by the way, you see what answer we got there? Where the two lines cross? What's our answer? 6 and 7. Okay? So, what you would do is just go over here. That's your answer. The ordered pair where they crossed is a what? 6 and 7. Now, what does that mean? Let me show you what this means. Because you can also use, you can take these numbers and plug them in if you wanted to. 10, parentheses, what was our x value? Our x value was a 6, minus, what was our y value? Our y value was a 7. You get 60 minus 7 equals 53. Over here, what is our y value? Our y value is a 7. It says our x value was a 6. So if I evaluated this, this is a negative 78. Negative 78 plus 92, that actually gets us to a 14. 14 divided by 2 is 7. So you can plug your values in and see which one works as well. All right. But since you guys have Desmos, what should you do? Just type them in, see what the 2 points mean. All right, moving on. Ooh, this one tells you what? This one is an exponential function. So by the way, it's very important to read what type of function you're dealing with. There's only 3 types of functions you're going to be dealing with. Okay? Linear, quadratic, and exponential. So those are the 3. Linear, / quadratic, and the last one, which this one is what? Exponential. It's the last one we're going to be doing today. Okay? So linear, the parent function for all linears is y equals x. The quadratic is y equals x squared. And exponential, typically it's in this form. Y equals a times b to the power of x. So that's linear, that's quadratic, that's exponential. So here's our table. We're just going to find the one that matches the same table. So this is your initial value. Okay? What you're starting with. What are we starting with? At 0, what are we starting with? 0.062 5. That's your, by the way, it's always going to be right here, 0, a. When x is 0, that'll be your a value. Automatically, we know it's going to be this one. But I'm going to show you how to type it in. Get back to calculate. Alright? So here's what I want you to do. Just remember, this says q of x. But this means y equals. So we're going to type in y equals. Ready? Y equals, type in 0.0625. Okay? Let me look at it real quick. Open parentheses, type in a 4, close parentheses, raise it to the power of x. And then what are you going to do? Hit second and check your table. I'm going to scroll down a little bit. I want you guys to see the table. Okay, we're going to stop right there. Take a look at the table. Do you see the table? That table does what? It's the exact table, which means that has to be our answer. So what's our answer? Answer choice H. By the way, anytime you see function notation, just remember function notation means y equals. Use your graphing calculator and check your table.
Where's table?
Oh, alright, forget it. You see the blue table button?
Oh.
So you have to hit second and then graph. Get second graph. Gives you the table.
Okay.
Glad you asked.